Okay, so let's do the first example problem, and it says, here's what's given. It says a 13-gram rubber stopper is attached to a 0.93 meter string. The stopper is swung in a horizontal circle, making one revolution in 1.18 seconds. Find the tension force exerted by the string on the stopper. So here we go. We got it. Now I always draw it, like we're looking at an edge on, like an oblique view or something like that. So here's the circle. Here's the rubber stopper. And here's the center of the circle. It's just going around like this. And it says that the radius is 0.93 meters. And it takes, the time it takes to go around once. Well, we have a name for that. The time it takes, pay attention. The time it takes to go around once, we call the period. And the period here is 1.18 seconds. All right, so here's what we're trying, and so what we want to know is, what we're trying to find is the tension in that string. Oh, and we're given the mass. The mass is 13 grams. Well, we can change that right away. 13 grams is how many kilograms? Cool? You want to watch this? Thank you. Okay, so this is 13 grams. And so how many grams in a kilogram? Kilo means 1,000. So you want to make this 1,000 times smaller. 0.13 kilograms. And so let's solve. Now I look at this thing and it's just moving in a circle. We are going to ignore gravity in this. If you include gravity, this becomes a fairly complicated problem. And so here's what we're going to do. We're just going to say, all right, the tension, if I draw a free body diagram of this guy, here's the mass, and here's the tension force. That's what we're going to solve for. I'm sorry, make that F sub t. We're going to find the tension force. In my AP class, we just use capital T for tension, but in here we use F sub t. So we want to find this tension force. Now, so if we ignore gravity, and you'll see why we can ignore gravity in a minute here. Well, if I sum the forces in the x direction equals ma in the x direction, well, there's only one force. There's the tension force. I did it again. Here's the force of tension is equal to ma. It's the only force, so it's causing the acceleration. But what kind of acceleration do we have? This is the kind of acceleration that makes things go in a circle. So we know that this acceleration is equal to b squared over r, right? That's what we showed. That's what the centripetal acceleration is. It's my speed squared over r. So, okay, well, the tension force then is equal to m times my speed squared over the radius of the circle. But I got a problem. I don't know what v is. I need another equation for v, for the speed. Well, what distance does this thing travel in one period? What is the distance around a circle? Yeah, it's 2 pi r, right? It's the circumference of a circle. So now we know that velocity, or actually speed now, is distance over time. Well, the distance this thing travels is the circumference of a circle, which is 2 pi r, over the time it takes to go around once. We define that to be the period. Now here's what the book does. The book just substitutes this in there, and you get this crazy looking equation. The book gives you an equation like this. It says that force is going to be equal to m 4 pi squared r over the period squared. Okay, if you substitute this in here, square everything, cancel stuff out, you get this. But this is a crazy equation and no one really gets it. But people understand this. Okay, my speed is the distance over time, once around the circle, divided by the time it takes to go around the circle once. We call that the period. So I always just calculate the speed separately and then substitute it in. So this is going to be 2 times pi times r. R is given to be 0.93 meters, divided by the period. Well, the time it takes to make one circle is 1.18 seconds. And so now I can find that. I've got my magical arithmetic machine here that uses quantum mechanics to do all this work for me. 2 times, where's my pi? Does it have pi on here? That's okay. 2 times 3.14159, more than enough, times 0.93 divided by 1.18 equals, and I get 4.95. How about 952 meters per second? So now I'm going to plug that in here. So the mass is 13 grams, which is 0.013 kilograms, times the velocity squared, or the speed squared, I should say, divided by the radius. And oh, I didn't do this very well. Divided by the radius, and so that tension force on the string. Okay, let's see. Square that times 0.013 divided by 0.93 equals, and the tension force is only 0.34 3 newtons. That was the book got it. Yeah, 0.34 newtons. Okay, so let's zoom out so we can see the whole thing. All right, so here's how you solve this problem. You're given an object, it's spinning in a horizontal circle. We're going to ignore gravity for now, just keep it simple. Spinning around, what's the tension force? Well, it's since the tension force is causing the acceleration, the tension force is equal to v squared over r, because we have centripetal acceleration, uniform circular motion. So we got v squared over r. Oh, but we got to figure out what v is, what the velocity, well, what the speed is, really. The speed is the distance over time. Get that value, plug that in here, and you got the tension force. Yes?
Wouldn't the 0.93, like, wouldn't the radius only like divide the v squared and not the mass as well, or?
Well, look what I did. I squared the velocity.
No,
but
I mean like the bottom, like the one, it shouldn't the mass like times like just like.
It's 0.013 over 1 times 4.952 over 0.93.
No, but like the mass is like.
Okay, let's hurry because I am recording this.
Oh.
You're being recorded. Okay, any other questions? That was Houston. That is all.